All right. Moving into the third Lords of the Dirt design consultant, a civil engineer plays a pivotal role in the design team. So, if you've listened to the previous episodes, we've talked about land survey, which is boundaries and slopes, and we've learned all about a geotechnical engineer in the next episode, which was a soils engineer about what's beneath the surface. Now, a civil engineer takes all of that data and then also design data from your architect and brings it together into a set of plans and specifications for the project to govern everything that happens outside the boundaries of your structure. So think about a civil designer is if you were to draw a perimeter about 2 feet around the building that you're about to build, everything outside of that to the property lines and even beyond the property lines is what a civil engineer addresses. Now it's a little hard for a homeowner to get that perspective because, well, how much really is there to that? You've got dirt, you've got the driveway, you've got some things out there, but I want to share with you what this is all about and why this is so important. So projects that would really apply to using a civil engineer would be projects that are probably on a little bit of the larger size, not necessarily, but for the most part, larger custom homes, meaning complex homes, large parcels, parcels that are sloping, that have complex things happening on them. A civil engineer can really bring a lot of value. Now, if you're working on a project that's a 60 by 100, 6,000 square foot flat lot in a normal neighborhood, you may not need a civil engineer. Sometimes an architect can appease the city requirements for what's required for drainage and other things that a civil engineer does. But don't immediately rule it out. It just depends on a lot of different things. And at the end of this episode, we'll ask your architect some questions that'll help determine if you think you really need one. But projects of new construction most certainly would need a civil engineer on more complex lots. Even significant expansions and additions that are on a sloping lot or other dynamics that are around that require a civil engineer. If you have installation of a new septic system, so you're not able to connect to a city or county sewer system, and you need to do an on-site septic system, civil engineers are the ones that design these, and the excavation contractors use that information to build the systems. One of the biggest things, and I know I've mentioned this before, but water intrusion is the number one killer of homes, and that usually comes from the site. It can come from a plumbing leak too, but in this case, it comes from the site. So a civil engineer will look at the dynamics of the property and the buildings and collaborate with your architect to place the home and the buildings in proper locations and then mitigate any of the drainage that's required on the project. So this is the things that a civil engineer does, amongst other things, and I'm going to get into the details. But these are the main core things that a civil engineer will do to help with the process. So let's go through. It's also becoming more and more of a requirement by the city and county regulations that they expect a grading and drainage plan. That's a term that's used a lot. And a grading and drainage plan is simply a plan and how you're planning to deal with all of the water that could be coming down your site, around your site, and the way that you're going to mitigate that so it doesn't affect the structure. Now, grading and drainage plans can be done by an architect if he has the proper information, but often a civil engineer handles that. So let's go through the things that a civil engineer really does. So a civil engineer approaches a project in this way. They first perform a site analysis, and they'll use the survey and topographic information that you've provided them to analyze the site from the boundaries and the slopes and conditions, vegetation, trees, etc. They will take that data and import that into their software and use that as their baseline foundation. So you can see that the survey topo is really important for the civil engineer, not to mention the soils engineer and the architect and the structural engineer. Then the civil engineer will poke his head up and look around at all the adjacent properties that might be coming into your property that could cause water or soil or hillsides or anything that could affect your property or your structures. One of the things that a civil engineer does is they handle mitigation of erosion. So any type of retaining walls or site walls that need to be built outside of the structure perimeter is usually the responsibility of a civil engineer. So they look at the existing conditions, they look at the proposed conditions by the architect, and they look at the adjacent properties, and they will propose any mitigation with retaining walls to make sure that erosion does not happen and cause damage to the property. Water management is probably one of the first things that's on a civil engineer's mind and should be on everybody's mind. And that is because, as I've mentioned, water can really destroy structures. It can cause erosion, where soil can then slowly work its way towards structure, changing the grade level and directing moisture into the building, into the foundation, under the house. One of the worst things you can do is have water flowing under your foundation and inside your house. So they even look at the architectural design, and they look at all the roof runoff and where that's going to be captured, and design a system to capture all of the roof runoff and deposit that into a storm drain system or what's called a dissipation pit on the property. Many jurisdictions now don't allow you to capture water on a site and then run it off into the storm drain system or other areas. One of the latest projects that I got involved in was I orchestrated all of the design consultants, and we ended up having the civil engineer design what's called dissipation pits, where we dig large, deep pits, fill them with gravel, and have all of the water end up there on site, and then it eventually seeps down into the water table. So that is the idea, is to return the runoff back to the water table on site. This is one of the newer requirements, and each jurisdiction's a little bit different, but that's what we had to deal with on this one. So keeping the water on site, the storm drainage systems, and preventing the water from intruding into the structure is a big one. Now, a civil engineer will work very closely with your architect, and they will determine together what is the best location and height of the structure out of the grade when it comes to mitigating any potential problems that I just mentioned. So you can imagine here, we have the soils engineer that's providing design criteria based on the survey. Now we have the civil engineer looking at the recommendations from the soil engineer, and then on the other side, looking at the architectural design. And they are literally deciding, should we raise the building up 6 inches, 12 inches, sink it down 12 inches more? What usually happens is the architect proposes a design, the location of where they want it on the property, and then the civil engineer either accommodates that or provides feedback, and they collaborate on where the building should be and where the height should be. So for example, in a project that I've recently coordinated the design of, this was a large project, more of an estate type project, and the civil engineer came back to us and said, if we lower the house a foot or 2 feet, it was maybe, we're going to be able to have a lot less excavation over on this part of the site. So you're going to get examples like that where A civil engineer is analyzing the design solutions with all the other data and making recommendations, not just for cost, but also for feasibility and mitigation of the things that he's responsible for, which is retainment of soil, which is water intrusion, water direction, slopes, angles. For example, the driveway can only be so much of a degree coming off of the street. So this is a person, architects don't necessarily think about all this stuff, although they can. And you get into more complex, bigger projects, it's nice to have somebody that specializes and focuses in on that. So grading design is the next thing we're talking about, which is what I just alluded to. So grading design is how the site or parcel is going to get reshaped based on the intrusion of buildings on this site. And there's terms that you'll hear such as cut and fill. So a project may require us to cut into a hillside and set it into a hillside perhaps, which means that some other areas will need to be filled up perhaps. So cut and fill is a term that's used and mostly by civil engineers and excavation contractors. What's wonderful about a civil engineer is that the sophisticated ones can tell an excavation contractor exactly or really close how many cubic yards of material needs to be cut into and removed from the site or removed from the area, and how much fill needs to be brought into the site or relocated to a particular location on a property. This is really important because this is how excavation contractors estimate their work. The amount and quantity of loads, the equipment that we'll need, whether the material needs to be taken off-site or relocated on-site. These are huge elements, huge components of providing an accurate excavation estimate for a project. If you don't have this data, you're leaving kind of everything wide open. So it could be where an excavation contractor would make some assumptions and then declare that in his proposal or contract, only to come back to you and say, we really needed to do twice as much, so now my bid's X amount more. These are surprises that if we can mitigate them, we will. And how do you do that? You do that with professional design, including civil design. So grading design is really important from that perspective. Another reason why grading is important is, like I mentioned earlier, retaining walls on a project can become heavily involved. And the taller they are, the more complex the design is. But retaining walls are just that. They are designed to retain soil, to retain a hillside, to create terraces, all different applications. Sometimes they're used to hold up driveways that are needed to be put in to gain access to the building. So a civil engineer's responsibility and deliverable is designing all of the retaining walls around the perimeter of the structure, anywhere that they're required on the property. With a proper survey and topo and soils report, the civil engineer is now empowered to design these retaining walls accurately. And what does this mean to you? This means a quality project. This means accurate estimates from excavation contractors and general contractors and home builders. This data is provided to all of them in the estimating and contracting process so that we've now reduced the surprises even more. This is a really big one, and this is why civil design is really important, especially on projects that are more complex. Infrastructure design is part of the scope of work for a civil engineer. And what I mean by that is any time there's driveways or access roads coming off a street into a property, those need to be designed and engineered. And you say, why? Are we just going to pour a driveway? It depends on the jurisdiction that you're in, but there are certain requirements for the width, the degree of slope, the size of the turnarounds. For example, the fire department, the local fire jurisdiction will have a say in your driveway design. And if it's certain length, if it exceeds a certain length, it requires turnouts and it requires turnarounds when they get up to the top of the driveway from a safety perspective. They also require access to around the entire structure. Who's thinking about all this? Civil engineers think about that. And this is why you need this. Because if you get into a situation where we just decide to do it on the fly because somebody thinks they know what they're talking about, and they get in there and they put your driveway in, and the fire department comes out to inspect, and you haven't put a turnaround in, you could be up for a drastic, major change order cost for the project. We're trying to avoid that. You're going to pay the money before or after. It costs a lot more money after because you're going to waste a lot of time and you're going to have to destroy a lot of things that got put in. So infrastructure design is really important, and it begins with driveways and accesses. Anytime you take a private driveway and you enter into a public right of way, such as a street, there are very specific requirements from the Public Works Department of your city or county. And civil engineers are well versed on how to deal with those and design the projects accordingly and show the excavation contractor and the general contractor exactly what needs to be done, from the square footage material of the driveway to the shape of the driveway for the turns in and the ingress and egress out of the property. These are the things that somebody has to figure out. And if you depend on somebody during construction to do that, it's likely that there's a much higher risk that you're going to make a mistake, and there's a much higher risk that you're going to have increased costs that were unexpected. So like I mentioned, the fire department compliance is also really important, not to mention the driveways and the turnarounds, but also any type of fire prevention or fire systems. For example, if a property is in an area, in a county area where there is a fire hydrant that is not close by, there's a chance you'll have to put one on your property. Isn't that crazy? I had to deal with that on a project where we didn't realize that was even a requirement. And we had to jump through a lot of hoops and end up having to design literally a fire hydrant on the property because the local fire hydrant was too far away. Not very many people know this. Civil engineers know this. Many home builders don't even know this. Many architects, it just doesn't come up often enough for it to be at the forefront of somebody's mind. A civil engineer, that's one of their categories in the infrastructure design, is fire. And what are we doing about fire? And how are we going to mitigate that? And how are we going to solve that? A big one too in the infrastructure design is the utilities. Now, somebody has to specify where power is coming from, the distance from there to the structures, the new structures, the depth of the trenches, the size of the conduits, the quantity of the conduits. All of these things apply to all of the utilities. So you have the power, you have the water, you have the sewer, which can be connected to a municipal system or an on-site system, and communications. All these things need to be thought out. Hopefully the surveyor that you hired earlier pinpointed all of the points of entry to the property, and then the civil engineer takes it from the point of entry to the buildings. So you may walk your property and see little boxes that have your power or water in them. Somebody has to figure out where that's going to go. And the reason this is important, again, is if we can document this within a set of plans for the project, the excavation contractor, the plumbers, the electricians, the communications contractor, all have something to go off of to price out. And best of all, now you have something that you can hold those subcontractors and your home builder accountable to do it. Not to say that they have bad intentions, but it's that this is how we get accurate pricing so that we don't get those Monday morning change orders. Oh, I didn't realize the phone line was over here. Now it's another 50 feet. So it's going to cost more, and so on and so forth. So the civil engineer will coordinate directly with the architect and locate those utilities wherever they need to go. Very important. Wastewater system. So a lot of custom homes that are built in rural areas or areas that don't have a municipal sewer system require a septic system. And if you're not familiar with what a septic system is, that is where you contain all of your waste from your plumbing on site. It never leaves the site, and it requires tanks and pumps, and leach fields are large areas of your parcel that eventually the waste permeates back down into the soil after it's been treated. Who designs that? How big is it? Where does it go? What are all the rules and regulations? Civil engineers know all of this, and they will design systems to accommodate the size of the home that you're building. Here's an example of one little thing that some people don't know, where a leach field could be a large area, could be 1,000 square foot area or more, that is designed to accommodate the waste after it's been treated. But you also have to have a secondary leach field allotment or an allowance for a secondary leach field in case that leach field fails. If you don't think about this early on and you just start plopping the structures around, not knowing that this provision needs to be in place, you could end up with additional costs and redesign, or worse, having to move buildings or make changes midstream during construction if somehow it got through all of the rules and regulations and permitting process. The planning department and the building department of your city will be reviewing the civil plans to make sure it's all in conformance and give you the green light to build it. And if it all goes right, that's one of the areas you've learned, oh no, I need to have a secondary leach field. So hiring a civil engineer for the wastewater system prevents all of that. And that's why right there, it's worth spending the money. All right, so let's talk about what a civil engineer provides, what their deliverables are, and why you need all of this information. So a civil set of plans looks just like an architectural set of plans. It's the large 24-inch by 36-inch plan pages usually in a custom home project. And they'll have a cover sheet that has all of their specifications and legend of the plan pages and a small map of the site. And then they'll get into what's called a hardscape plan. A hardscape plan is all of the patios, walkways, driveways, anything that is going to be constructed out of concrete, masonry, asphalt that will be on the site. And the reason they do this is that they do a calculation. You may recall in previous episode, we talked about impervious surfaces. We talked about lot coverage, things like that. They will do the calculations to make sure that they are in conformance with the rules and regulations from your county about how much we can have of these areas. Another really valuable reason to have the hardscape plan is that this provides some data points for concrete contractors, landscape contractors, and general contractors to provide their estimates based on this data. This is another reason why it's worth hiring a civil engineer, is now you know your costs up front. The caveat here with specifically hardscape plans, and one that we have not talked about yet, is landscape design. Civil engineers are not landscape designers per se, but they do start to go down that path. If you have a project where landscaping is important to you and it's maybe a little bit more custom project, you may want to consider bringing in a landscape designer at this stage of the game and work hand in hand with a civil engineer to get the hardscape design as close as possible. These are one of the areas that often change during construction. Once you as a homeowner see the site and see the conditions, you may make some changes. But 1 out of 10, if you can get to a 6 or a 7 with level of details in the hardscape plan, the better you are. The more accurate costs you will have to begin with, the less surprises you'll have. So a hardscape plan is really important from all different types of aspects. A grading plan, like we talked about, is literally pages of plans in this set of plans that show where all of the cut and fill I was talking about go on a project. A grading plan also looks at a site from a side view, and the civil engineer will show the shape of the lot, the slope of the lot, and actually show where the cut and fills are on the plan to help an excavation contractor visualize what's happening. Again, another thing to help identify accurate costs, to hold everybody accountable, to build the project to your expectations. You don't necessarily need to learn how to read all these, but you need to know that cross sections is what they're called. So if you were to slice through a dollhouse and you can see the inside of the dollhouse, that's kind of what it is. And we're showing where all of the work is going to happen. And he does it through different parts of the lot to convey the scope of work to an excavation contractor. Pretty important. The utility plan is a completely separate page that will show where all the utilities go from the street or from the points of entry to the structures, but also any utilities and conduits, anything below the ground, outside the perimeter of the structure that need to go in. You may have outdoor structures. You may have a cabana that needs to built that needs power. You may have a pump house. You may have different things, landscape lighting. You may need power to your septic system. All of these things go into a utility plan. And this is also the scope of the work of the excavation contractor to provide all of the trenching and all of the conduits for those utilities. And then your plumber and your electrician and your communication subcontractors come in and connect to all of those. So again, having this documented on the plan set, civil plan set, is just going to empower you even more and protect you even more when it comes to getting the actual work done, but also getting accurate costs up front. The septic design is part of the plan set as well. And a septic design, depending on the complexity, will show the location of the tanks, the location of the pumps if they apply, and the location of the leach fields. A civil engineer will also specify the equipment, the make and model, down to that level of detail to convey that to usually an excavation contractor that installs those systems. So once again, we have a situation where you're going to be able to point to my excavation plan or my grading and drainage plan or my septic and sewer plan or my utilities plan and say, I want you to price it out per the plan, per the scope of work. Now, if you don't have everything on there, it's on you. If your architect doesn't have everything on there, it's still on you, by the way. But at least you've taken those steps by hiring a civil engineer. Again, we're trying to mitigate any kind of problems that could come up. Other reports that go along with a set of civil plans is a stormwater collection plan. Now, this is because a lot of cities and counties require it, and they will come up with a plan of how all of the stormwater is going to be collected and dissipated onto the property. Like I said earlier, you probably can't dump it out onto the street. Some jurisdictions you can, and that's great. That just simplifies the process. They will do an erosion control plan. So during construction, there are certain elements that need to happen, certain components that need to get put into place, physically installed on the project to manage the erosion during construction. This is really important because it's required by the city and the counties, and they will require that. So you might as well develop a plan to do it so that you don't have mud flowing into your brand new house during the construction. And then they will provide calculation packages based on all of this stuff for the city building department to scrutinize. I hope this is making sense. I know it's a lot, but it's important that we just at least get it into your head, and then you can decide if you really think you need to use this design consultant. Visualize this. You have a round table, you have your architect, you have your surveyor, you have your soils engineer, and now you have your civil engineer. All of these people collaborate together during the design process to ultimately get the best end result. Now, one of the mistakes homeowners make is they do not authorize some of these things to happen. whether it's for cost or for time sensitivity. A classic scenario is an architect suggests that we hire a civil engineer, and civil engineers can be anywhere from 5,000 to 25,000. It depends on the complexity of the project. Of course, they could probably save you $200,000, but nobody likes to look at it that way. They like to look at the actual output of money versus the intangible potential savings, and not to mention actually meeting your expectations with a project. So I call it handcuffing a designer, and I've spoke about that in the earlier episodes. But if an architect recommends you hire a consultant, I recommend you do it because they are thinking they need it. And if they think they need it and you have no idea what you're doing, you might want to think about just doing it. So don't handcuff your designer too much on that. We need all of these people together to do the best project possible. So the time to engage with a civil engineer is usually in the early stages of the schematic design, the first step of design. So we have the survey in hand, we have the soils report in hand, the architect's beginning to conceptualize the design. The conceptual design has gotten to a level where the soils engineer has been able to use it. Then you bring in the civil engineer right there, because the civil engineer is going to look at the conceptual design, the very early stage of design, and hopefully your architect has imported that into 3D software modeling so that you can see it, but also the design professionals can see it. And this is the time where the collaboration becomes the most valuable, because a civil engineer can make recommendations of where to locate the buildings to mitigate cost, to mitigate water intrusion, to mitigate erosion, all these kind of things, to reduce the cost of getting the utilities to the buildings. But for the most part, the architect is driving that design because there are certain design elements that the civil engineer isn't thinking about, such as the view, such as the neighbors and the privacy, all these different things. So the technical mind of an engineering mind of a civil engineer is where they're focused on, not necessarily the overall look and feel of the home. So there's collaboration and compromise that happens. So that's when you bring in a civil engineer to the project. So let's talk a little bit about the costs and the value that civil engineers can bring to a project. I have seen civil engineering range from 15 to maybe 10,000 to 25,000, 35,000 and beyond. And it's all going to be dependent on the project. A civil engineer's cost could represent maybe 2%, 2 to 3% perhaps of the overall cost of construction of a project. A civil engineer is one of the more significant design consultant expenses. The architect probably being the most, structural engineer being the second, and civil engineer probably being the third. But sometimes the structural engineer and the civil engineer can get close together if it's a larger parcel and a more complex project. But it influences like 100% of your project. This is the foundation of the project, literally. They are developing the foundation of the project with all of the other data that we talked about, such as the survey, the soils engineer, the architectural design. And they are like the foundation of quality, the quality of the home that you're doing. So the good civil design, they elevate the entire project standard, and they set expectations for quality throughout all the trades that are going to become involved in the project. So let's look at some of the value factors, I call them, of a civil engineer. It's design quality enhancement. So they're providing the architects with accurate data for optimal home placement. It reveals like opportunities within the site to even increase the property value, and it prevents design compromises due to poor site planning. These are things that not a lot of people think about. Design professionals do, but a lot of homeowners don't think about the value here, and it's hard to pinpoint the value here. But once you see it come about and you start seeing the evolution of what a civil design brings, and then when you're living in the home and you watch the water flow right by and not through you, now you get it. A big one is the construction cost certainty, right? So the more detailed the plans we have in civil design, the more accurate the costs you're going to have, the less surprises you're going to have. It's an accountability tool for your general contractor and then his subcontractors, which one of them would be the excavation contractor. Unless you're an owner builder, then all the more reason you need them. They can't really, they can't really claim unforeseen conditions, at least not to the degree that they could have if there was no plan. This can reduce change orders substantially. This also gives you peace of mind for long-term protection. It ensures that your compliance from a regulatory standpoint. It protects your investment for decades, that you don't have problems to deal with. If you've gone out and looked at homes for sale, past homes that have been built, and problems, a lot of it could be done. A lot of it could be because proper grading and drainage wasn't done. Proper retaining walls weren't put in. The utilities are way too far away, things like that. So you can foresee problems by looking at other properties or properties maybe you've lived in and how you can mitigate that through civil design. All right, we're getting towards the end, so let's go back to our Q&A session with contractors, with architects, with designers. So here's some red flags to avoid when you're interfacing with potential designers or even one that you may have already hired, or contractors who say, oh, we don't need an engineer. I've been doing this for 30 years. I can just design it on the fly, and why spend the extra $10,000 or $15,000? So what happens there? So now you've been talked out of potentially hiring a civil designer. What methods do we have to hold anybody accountable, and who assumes the liability when it didn't work? Your contractor is offered to do that on the fly, so I suppose he's assuming the liability, but is he really, when it really comes down to it? I think as a homeowner building a custom home, having a third party and having an accountability tool to actually use to make sure things get done right, priced right, makes sense to me. So that's what we're talking about here. This sometimes goes to not wanting to get the proper permits from the county for grading and drainage and things like that. And we're not really interested in that and building a quality home or experience. And the other one is ignoring drainage issues. In the past, people have just put that off to the side and said, oh, don't worry about it's drainage. We'll worry about it later. We'll figure it out. It's not that big of a deal. It can be a big deal, especially if it's not addressed or not addressed properly. And the way to address it properly is in a civil design. So don't let drainage, grading and drainage feel like this low priority when you're thinking about your project. So let's ask the right questions. What assumptions have been made in my design? Asking your architect or designer, what assumptions have been made when it comes to everything outside of my boundaries of my home? What could change during construction based on the path that your architect's proposing, or maybe your general contractor is proposing? Do we need permits for this? Let's ask these questions just to strike up dialogue and so that you can learn and know a little bit more about what you don't know. And do we need a civil plan? Now that you might need it, asking that question's going to make the architect go, oh, maybe this person knows what they're doing. Yes, we should probably get one. And that is the answer you're wanting to get. So asking these kind of questions spurs that conversation. And one of the ones also comes up is, how am I going to get accurate prices on all of the work associated with the lot and the drainage and the utilities? What is the best way to do that? And if the word civil design doesn't come up and things like, we'll just ask the contractor to bid it, again, we're back in the same boat. So asking some of these questions early on before you hire a designer, or maybe right after you hire a designer, hopefully before, because then you'll understand the design costs up front before you start diving into your project. Here's a fun one. The job I was doing on earlier I mentioned in the estate, I actually waited till a winter storm and I walked around the whole site and watched the water flow. And I watched it flow right to where the house was going to be. I took videos of it all and I posted it to the civil engineer that we had hired and said, just so you know, here's something helpful. And I got it from all different angles to show him how the water was flowing. He probably had an idea because of the terrain, but seeing it really live was interesting. Understanding those water flow patterns Knowing the soil conditions where you see erosion occurring and not can also help a civil engineer and an excavation contractor design solutions properly. So budget for civil engineering early. It's really a foundational aspect of custom home building and design. It really shouldn't be optional. Allow time for that to occur and make sure that you're integrating your architect into these decisions. Talk with him or her about that and expect some back and forth between the civil engineer and the architect and the county, frankly, back and forth, trying to come up with the right solutions, raise it, lower it, move it, shift it, change it, retaining wall high or lower, retaining wall over here, things like that. That's all part of the fun part of design that ultimately gets you the best end result. I hope I've been helpful with this civil design aspect of the Lords of the Dirt series within the world of design that we're on right now. If you have any questions, and which I'm sure you will, I will be available. I'll be available with consultations, emails, that kind of stuff. And that's what I have for you today to wrap up the Lords of the Dirt series. I know I was all over the place a little bit, but I was hoping I'd get the main points to you to get it out and on the table. And the transcript and the show notes and the summary will all be included in the podcast episode and the YouTube video for you to go back and look at. I'm Bill Reid. This is the Awakened Homeowner. Thanks for joining.